Hi folks, we're going to take a look at this question from the homework. So what we're looking at is the movement of a paddle on a riverboat. Okay, so it's turning around and around and it goes partially underwater. So they give us the radius of 3 meters and they tell us that it goes 1 meter underwater. Okay, it gives us information about revolutions per minute, so I guess we'll use that to find the period. All right, and now the way the time is measured is interesting. It's measured with respect to this side beam, okay, which is at an angle. So first of all, we realize that this does not start, doesn't look like this is at the horizontal, okay, and it doesn't look like it's starting at the maximum or the minimum, so we know we're going to need a phase shift at some point. All right, so let's try to figure this out. And this is one of these scenarios where I really think drawing out a picture of the situation is going to be useful for us. Okay, so let me do that here. So we've got this wheel that's going around, and it looks as though the water level is somewhere there. All right, so we know that our minimum height is going to be -1 meter below, and our maximum, well, let's take a look. If the radius is 3, okay, so from -1 plus 6, the diameter is going to be equal to 5. So there's our maximum height. All right, and we're starting from where this side beam is, which they tell us is pi over 4 radians from the horizontal. So notice, not from the water, but from the horizontal. So here we have pi over 4. Now it looks as though we're going to be working in time. So at a certain point, we're going to have to, or in fact right now, what we'll do is let's translate this measurement in radians into a time measurement. All right. So I think what's going to be helpful is to figure out what the period is. Okay, so what do we have? We have that it goes 15 revolutions per minute, and I want to know how long it takes for 1 revolution. But given this 30 seconds here, and given the fact that we're going to be in portions of a minute, I think I'm going to put this in seconds. So there's 15 revolutions in 60 seconds. Okay, so that means if I want 1 revolution, let's divide numerator and denominator by 15. So it takes 4 seconds, okay, for 1 turnaround. Okay, so our period is equal to 4 seconds. Now that's kind of nice because it's obviously divisible by 4. And I'm going to use this to help me determine the time of my phase shift. Okay, now this is where I have a choice. It looks like given where I start counting time, I could either compare that to the maximum or to the middle value. Now since we use cosine quite a bit, I'll use sine this time here. So I got to figure out how much time does it take to get to the middle here. Well, think of it this way. The whole period is 4 seconds. So for example, to go from the maximum point to the middle would take 1 second. Okay, and pi over 4 is exactly half of pi over 2. So that means it'll take 0.5 seconds. That's the difference between our starting value and the middle value. All right, so our phase shift is going to be 0.5 seconds. All we have to do is figure out in which direction it's going to be. All right, so before I figure out the phase shift, let's figure out all the other things. So we've got A, our amplitude is going to be the max minus min divided by 2. So our A value is 6 over 2 is 3. Then we've got our C value, which is 5 plus -1 over 2. So 4 over 2 is 2. All right, we've got our K value, which is just going to be 2 pi over the period, which we determined was 4. So pi over 2. All right. And since I'm going to be starting at my middle value, since I'm going to be using a sine value, a sine function, and notice here, it's telling us that it starts at this point and goes down towards the water. So I didn't mention that before, but that's why I drew the arrow in this direction, because it tells us that it starts moving towards the water. Okay, so that means I'm starting at my middle value and going downwards, which means my parent function is going to be equal to, is going to be negative sine x, because I'm starting at the middle value and going down first instead of up. All right, so now let's figure out in what direction this phase shift is going to go. So as I usually do, I'm going to draw myself a picture that doesn't involve a phase shift yet. So I've got some function that's going to look like this. Okay, that's negative sign. So again, goes down first, then up. Okay, but I want at the start to be further above the horizontal. So that means I'm going to have to move. Okay, so if you think of this as my function, I'm going to move it in this direction so that I'm actually starting above the middle value. Okay, so that means I'm going to be going to the right. So my phase shift is going to be equal to 0.5 to the right. And so now we have all the information we need to come up with a model. Okay, so here we'll say let h be height above water, and let t be time in seconds. All right, so my model then is going to be h equals, so it's negative sign, so negative 3 sine of, my k value is pi over 2, and my phase shift is 0.5 to the right, so it's going to be t minus 0.5, and then plus 2. So there's my model. So if you were going to use a cosine function, so comparing the start value to the maximum, okay, so you'd have a cosine function, and I suspect that you would be doing your phase shift to the right. So your function would probably be 3 times cos of pi over 2 t plus 0.5 plus 2. Okay, but in the end, remember, they represent the exact same function, so they should generate the same answers later on. All right, so let's go on to solving the actual problem. We want the times at which the paddle is below the water level. So essentially what we're trying to solve is for this function to be less than 0. So we're essentially solving a trigonometric inequality, but we're going to solve it the way we've solved almost all our other inequalities, is we're going to start by finding where this thing is equal to 0. All right, so that's step number 1. So we're just going to solve the equation, negative 3 sine pi over 2 t minus 0.5 plus 2 equal to 0. Okay, this is a linear trigonometric equation, so step number 1 is just to isolate the trig ratio. Okay, so bring the 2 to the other side. So negative 2 divided by negative 3 is just going to be 2/3. Okay, so in terms of solving our equations, we got step 1, isolate the trig ratio. Step 2 is determine two values whose sign is equal to 2/3. So because 2/3 doesn't correspond to a special angle, I'm going to use my inverse sine button. So pi over 2 times t minus 0.5 is going to be equal to, so our first answer is going to be given by the inverse sine. So let's get this here, inverse sine of 2/3. All right, and that's equal to 0.73. Okay, or of course, the other option is pi minus this answer, okay, since we're working with sine. So 3.14 minus 0.73, so that's just equal to 3.14 minus 0.73 equals 2.41. All right, so now we have our two possible solutions that we get from sine, and so now let's solve for t. Okay, so I'm not going to write out all the steps here. So what do we do to solve for t? Well, we're going to have to multiply the number by 2, divide it by pi, and then add 0.5. And I'm going to do the same thing with the 2.41. Okay, so in the end, I'm just solving a linear equation by opposite operations. So 0.73. So remember, we said multiply by 2. Okay, then divide by pi, and then add 0.5, and we end up with 0.96. Okay, or in this case here, we take 2.41, again multiply by 2, divide by pi, and add 0.5 and 2.03. Okay. So all we have to do now is figure out which one of these represents going in the water and which represents going out of the water. And this is where I'm going to go back to my graph, which I drew earlier. And I see that the first time I have an x-intercept, okay, 0.96, is when it's going into the water. Okay. And then here we see it's coming out of the water at 2.03. Okay, so as I, then add 2 pi, that's the next time it goes in the water. Add, sorry, not 2 pi, add the period, which is, where is the period? It was 4. When I add 4, that's going to be the next time it goes in the water. Add 4 to this one, the next time it comes out of the water. So this is going to represent in, and that's going to represent out. Now I just realized here that maybe 30 seconds was a little too long to take, but because these numbers are pretty small. So instead of actually writing down all the values, I'm going to start, where it's equal to 0, I'm just going to start writing my inequalities. Okay, so here my answer is, so the first time it goes in and out, so it's, remember, we're looking for when it's underwater. Okay, so when's it underwater? And here we'll assume t is in seconds, so I don't have to write it each time. Okay. So the first time it's underwater is between 0.96 and 2.03. Okay, the next time, so remember, what's the period? The period is equal to, okay, where's our period? We wrote it down somewhere. There you go. It's 4 seconds. So I'm going to add 4. The next time it goes in the water is going to be 4.96. So less than t, less than, the next time it comes out of the water is going to be 6.03. And now I just keep going. Okay, the next time it goes into the water, let's add 4 to this. So 8.96, less than t, less than, add 4 again. So 10.03. Let's keep going. The next time it goes into the water, add 4 is 12.96. Comes out of the water, 14.03. All right, the next time it goes into the water, add 4, 16.96. Okay, this is going to be long. Okay, add 4, 18.03. Okay, add 4 again, so 20.96. Add 4, 22.03. And we just keep going. Add 4 here, so 24.96, less than t, less than, add 4, 26.03. And here, if we add 4 again, we have 28.96. But if we add 4 again here, we're going to go slightly over 30. We're only interested in up to 30 degrees. So 30 seconds. At 30 seconds, it's still going to be underwater. So my last answer here is going to be less than 30. I'm not going to include the 0.03 because this is where it stops and I'm still underwater here. All right, so this was a long one because there are a lot of things going on. Let's do a recap here. Okay, step number 1 was to identify, given the information, are A, C, and K. Okay, so here they didn't give any of this to us directly, I guess, other than the minimum value, which they gave to us directly. Okay, we used the angular velocity to help us figure out what the period of one rotation is. Okay, and then we determined, based on how they described the starting value as being pi over 4 from the horizontal and going into the water, we were able to figure out what parent function to use and what phase shift we needed to accomplish the task. Okay, so once we had our model, we realized that we were solving this inequality for when this height is less than 0. And we solved the inequality the way we do all inequalities, or almost all of them, except linear ones, is we started by finding the actual zeros. All right, so we found our zeros, and then from there, instead of testing intervals like we would have done in the past, we used the graph to interpret that this first value was when it goes into the water, and that second value was when it comes out of the water, and then we just use the period to determine all other intervals in which this occurred. Okay, that is it for this one.